Alright, let's start with number 5, equations with two absolute value expressions. Consider the absolute value of A equal to the absolute value of B. This means A and B are the same distance from 0. If A and B are the same distance from 0, then either they are the same number or they are opposites. Recall, when you think about absolute value, it means finding distance, right? So you can rewrite this notation as, right, A subtract 0 is A, equivalent to the left-hand side. Now, this absolute value of A means that find the distance from A to 0, okay, or the distance from 0 to A. Similarly, we can say B is the distance from 0, okay. We're given this, the distance of this A and B from 0 are the same, okay. They are same distance away, okay. They're same distance away. So it means either they are the same, meaning they are both positive, some distance, positive distance, okay, positive, okay, on the positive side, okay, they're on the positive side, okay, or they're on the negative side. Okay, so if they are the same, meaning they are either both positive, both negative, or the opposites, meaning one on this side and the other on the other side. Okay, but importantly, they still maintain the same distance. So that's what it means. So I'll start with solutions for this exercise. Given absolute value of y minus 6 equal to 6 minus y. Absolute value, solve. So we know that P2 are distance from y to 6. Okay, for this k is spelled out the constant. So y is the distance from 6, or from 6 to y. These are distance. So if they are the same distance, right? Distance 1 equals distance 2. If they're the same distance, then either they are the same number, meaning y minus 6 equal to 6 minus y. They are the same number, okay? Or they are opposites, meaning they are on the other side. So y minus 6 equal to the opposites, right? Opposites mean negative. One positive, negative 6 minus y. Okay? So again, we need to solve the two equations to find y, which is solution of this equation. To simplify this, we can combine the y. So I will start with plus y on both sides. If I do that, I can eliminate this y right here, and I keep the y on the left. You can do the other way as well, but I will start with this. Y plus y is 2y minus 6 equal to 6. There's no constant here, so 6 plus 0 is 6. Negative y plus y is 0. Simplify, we get 2y minus 6 equals 6. 6 plus 0 is 6. To solve for y, we need to eliminate this constant term. We do that by using the addition principle. 2y, then no y here means 0, so 2y plus 0 is 2y. Negative 6 plus 6 is 0. 6 plus 6 is 12. 2y plus 0 is 2y, equal 12. Divide by 2 on both sides to solve for y. Okay, we get 2 divided by 2 is 1. 1 times y equal to 12 divided by 2 is 6. So 1 times y is y equal to 6. So we have solution for this equation is y equals 6. Now, here's another or right here. We need to solve this equation as well. So y minus 6, it has parentheses. So to remove parentheses, we need to distribute this to each term inside the parentheses. So negative here, just like -1. So -1 times 6 is -6. -1 times negative y is positive y. Okay. Now, to solve for y, we can combine the y together. Let's subtract y on both sides. Y subtract y is 0. There's no constant here, so it's -6 plus 0 is -6. There's no constant here, so -6 plus 0. There's no means 0, so -6 plus 0 is -6. Y subtract y is 0. Simplify, we get -6. -6 plus 0 is -6. Does -6 equal to -6? True. Right? So if it's true, that means this equation and this equation right here, which is y equals 6, right? It means that there are all real numbers. All real numbers are solutions of this inequalities. So let me write the answer here. For part A, thus there are, the solution are all real numbers. Okay. Since this second equation right here to show that -6 equals -6, it means that any values, any real values, are solutions of this equation. And this equation right here also includes the solutions, which is y equals 6. Y equals 6 is a real number. It's one of the solutions, right? So we don't need to restate this answer. All we need to say, thus the solutions are all real numbers. It's already include this answer right here, y equals 6. Okay. So that's the example for 5. So I have another example here. I'll give you a moment to copy. Oh, sorry. I still need to show. I need to graph it. Apologize for that. So now we know that all solutions of this equations are all real numbers, right? If you draw, let me erase it. If you draw a number lines, right? So this number line go in negative infinitely to the left, positive infinitely to the right. So which point is that show all answers of these equations? All real numbers, right? So actually all solutions of these equations are on this number lines. Okay? Every point on this number lines are solutions of this equation. So you just draw a line that on top of this number line, and make sure you show the arrow on both sides. It means it extends infinitely to the left and extend infinitely to the right. Okay? Because this case, all solutions, all real solution on the number line are solution of this equation. Okay, let's start next example I have. Given solve for part A, and B is graph. So So this is okay that on both sides of the equation both sides of the equations have absolute value, okay? So we use this expression right here. Let's say if A and B are the same distance from 0, then either they're the same number or they're opposites. So it means same number, right? Same distance means x minus 15 equal to x plus A. Either they're the same or they are the opposites. Opposites mean negative. Okay? So we have two equations again. Let's solve this. Start with this one. Let's subtract x on both sides. X subtract x is 0. Negative 15 plus, then no constant term here, means 0. So negative 15 plus 0 is negative 15. X subtract x is 0. A plus 0 is A. Simplify. 0 minus 15 is minus 15. Equal to 0 plus A is A. Now, do you see anything strange? A negative number equal a positive number. Impossible, right? So you say false. Okay. And then move on to the next case and see how it's like. Remember, at the end, we'll compare the answer from the two equations to make the final conclusion for the equation of this absolute value equations. So, because it had parentheses, we remove it by distribute. Negative 1 times x is negative x. Negative 1 times a is negative a. Let's combine the x together. I'm going to keep this x and I'll eliminate this x on the right. If I want to eliminate this, it already subtracts. So adding what will make this negative x goes away or equal to 0, which is positive x, right? So x plus x is 2x. Negative 15 plus nothing here, which is negative 15. Or negative 15 plus 0 is negative 15. Negative x plus x is 0. Negative 8 plus 0, there's no constant here, which is negative 8. Simplified, we have 2x minus 15 equal to 0 minus a is negative 8. Solve for x, we need to remove this constant term. So we plus 15 on both sides. 2x, the no x here means 0. So 2x plus 0 is 2x. Negative 15 plus 15 is 0. Negative 8 plus 15 is what? 15 subtracts 8. 15 divided by 8 is 7. So we have 7. Remember, the positive number is bigger. If the number that's bigger is positive, it has the sign of that number. 15 and negative 8. 15 is bigger, so we keep the sign of the bigger number, which is positive 7. 2x plus 0 is 2x, equal to 7. Divide both sides by 2 to solve for x. 2 divided by 2 is 1. 1 times x, 7 half. So 1 times x is x. X equals 7 over 2. So it turns out there's no solution on this left equation. There is one solution on this right equation. Thus, there's only one solution for this equation. So, let me copy the answer here. So part A, the answer is x equal to 7 half. Okay? In the book, you would say, they'll write the answer as set. 7 divided by 2 in braces. So for part B, we need to graph this. So I'll give you a moment to copy this. Then grab it. This number line, okay? So when we draw an equation, it means we draw the solution of the equation. So there's only one solution, right, which is 7/2. So you just pick one point on the number line and label 7/2, and that's all you have to do for part B. So this is the graph of this equation that shows the solution of the equation. Right? So this, I'm finished part 5, which is equation with two absolute value expressions.